Hello, everybody. Today I'll be speaking about audience retention of YouTube videos. I will start with a short introduction on how to measure success of a video on YouTube. We have been studying various approaches to measure virality of videos. The first is through the study of the view count process. We analyzed 80 million videos chosen at random from YouTube and identified 6 mathematical epidemic models that turned out to match over 90% of the videos with a mean square error no larger than 5%. This enables one to predict the view count evolution according to the epidemic model that the video has had so far. A possible application of virality prediction is for caching, where caching decisions can be based on the predicted virality. A popular video is not only highly viewed, but it may also stimulate creation of other similar videos. For example, videos with the same music or with the same dance. Examples are Happy and Harlem Shake. Thus, a second way to measure the success of a video is through a study of internet memes. The concept of memes was coined by Richard Dawkins, and it is a concept for describing the spread of ideas and of cultural phenomena. We study propagation through collaborative creation of videos here, using Google Trends. A third way to measure the success of a video is through the study of audience retention. And this is the object of this talk. Audience retention measures the behavior of the audience of a specific video during the time they watch the video. High retention indicates potential to become popular. And the retention in general is a way to predict popularity way before we have much data on the video. The data on audience retention of a video is not publicly available and is provided by YouTube only to the video creator. We have therefore created more than 1,000 videos since 2012. And I just mentioned that our most popular video has now 1,200,000 views. The work I report here was performed during the summer of 2017. It is based on 4 of my 10 channels of YouTube. In this talk, I'll describe ways to measure retention. I'll describe the way YouTube measures them, and then say a few words about the structure of the retention graph. And then I'll describe the behavior of these measures and the weakness of some of them. In particular, I'll speak about 2 issues, which is consistency and continuity of retention measures. And then I'll finish by proposing a new measure and show its performance. The objective of the study is not to provide a statistical analysis of retention. It is rather to develop tools that provide meaningful feedback for a single user or for improving a single video. At the same time, we shall see how these tools enable us to understand audience behavior and to take decisions on the video, like the duration of the video. Audience retention can provide a measure for the potential of a video to go viral way before we actually have the figures in terms of view count on its virality. It can be used to select videos for uploading to caches, and the first reference I give is an example for that. It can be used by companies to improve videos that they release. For example, pedagogical videos. And second reference I give is an example for that. Finally, it can be used for advertisement decisions. It can be used to decide where and when to place an advertisement by using data on the retention of the film into which we wish to add advertisements. Here is the retention data that one gets from YouTube when you produce a video there. So it is called a retention graph, and you see it in figure 1, where the horizontal axis is the time that goes from 0 till capital T, where capital T is the duration of the video. The vertical axis is the retention, which is the percentage of people that watch the video at the given time T. YouTube calls this X of T the absolute audience retention, AAR. As we saw in the previous figure, a typical retention graph has 3 parts: the nose, the body, and the tail, which corresponds to the beginning, the core, and the end. According to Fishman and Carrier, there is a large drop in engagement at the very beginning of the video, a steady drop over the middle section, and then another inflection point at the end. And this is why we present these definitions. We may expect retention graphs to be always decreasing and never to exceed 100%. But it turns out that they can be increasing already from the beginning, and they can exceed 100%. So here is an example. Now, when does this happen? This happens if a user watches more than once the same video, and he does so by dragging the cursor to the beginning of the video. By the way, this is the video that has the best retention among my collection. example of retention graph that may be increasing. So this is called a U-shaped nose, which occurs when there are long introductions before the video actually begins. The last figure corresponds to a video we made in January 2016, in which the conductor describes the piece that is going to be played for 1 minute. In all 14 videos of the concert, the nose keeps the same shape. It is due to the fact that viewers are interested in the music and not in the explanations which they skip. 1 year later, we filmed exactly 14 more videos in a concert with the same orchestra and the same location, without including the conductor's long introduction. And figure 1 is an example of that. And in all these videos, the U-type nose indeed disappears. To quantify the audience retention in one number, YouTube provides 2 indexes. The first is called APV, average percentage viewed, and the second AVD, average view duration. Here is an example how we can improve the retention of a video by shortening it. This example is of the song Sur le Pont d'Avignon. The original duration of the video is 5 minutes and 51 seconds. We shortened it to 2 minutes and 33 seconds, which resulted in an increase in the average percentage viewed APV of 16%, from 16% to 42%. The average view duration increased by 2.625, while the whole video duration decreased by 2.294. So not only did the average viewed time increase, but it did so by a factor larger than the amount by which we shortened the video. So what can we say in general about shortening a video? We shall now analyze the shortening of videos, and for that we have to define what is a causal shortening or a causal video. The definition: a video is causal if the corresponding retention x of t is causal, that is, it is only a function of events that occurred before time t. And causal videos have the following property. If the video is defined on the interval 0t, and we shorten it to 0s for some s smaller than t, then the retention curve of the shorter video is the same as the initial one restricted to 0s interval. When do we gain by shortening a video? We always gain in the average retention when shortening a causal video, with strict inequality if the retention graph is strictly decreasing. A small calculation shows that the gain is upper bound by the ratio between the duration of the videos. So the gain in shortening the video is bounded by the duration of the longer video divided by the duration of the shortened one. And this is an asymptotically tight bound as x of t decreases to 0 on the interval t2 to t1. When are the gains of shortening a video insignificant? Consider a causal video of duration t1, which we wish to shorten to a duration t2. Assume that the retention curve has two phases, a nose which is short in time, the duration of the nose is of order of epsilon, and then in the rest it is constant. In that case, the amount that we can gain is of order of epsilon. So we conclude that if the audience retention x of t goes to 0, then we can get significant gains by shortening the video. Whereas if it stays bounded away from 0 during a long time, then we cannot gain significantly. So here's an example. It is a video of paintings of Nabil Anani, who is a well-known Palestinian artist, and it's accompanied by my music. Now, from the musical point of view, it makes sense to shorten it after 4 minutes and 20 seconds. So should we or shouldn't we? So if we look at this retention graph in figure 4, we see that it is bounded away from 0 during a long period. So this suggests that our gain by shortening the video will be limited. The metrics we saw so far favored shorter videos. So is there a way to compare videos of different durations in a fair way? To compare the retention of different length video, YouTube introduced a measure called relative audience retention, RAR. It consists in normalizing each point xt of the original video by the value average of t, obtained by averaging xi of t over all I in the set capital I. The set capital I is the set of YouTube videos which have the same duration t as the original video. At each point in time, the relative retention can take a value between 1 and 5, where the integers 1 and 5 correspond respectively to the categories low, below average, average, above average, and high. These categories are similar to the Moss measure for the quality of experience as standardized by the ITU. So here is the RAR for the same video that we saw before. It confirms not to shorten at 4 minutes 20 seconds, because at that point we see that the RAR grows from 3 to 4. What can we say about the relation between the relative and the absolute audience retention? We look again at the video that we saw in figure 3, which gave the absolute audience retention. We now look at the relative audience retention in figure 6. We saw that again, like in the previous video, the audience retention in the absolute AAR metric remains bounded away from 0. It's about 33% all the way to the end. And we see that, as we saw in the previous one, that this means an improvement of the ranking of this video and the quality of this video, which moves up from 2.6 to level 4, where 5 is the maximum. This motivates us to introduce a new audience retention measure, which is the fraction of the audience that remained till the end of the body of the video. We call this the loyalty percentage measure. What are the advantages of using this new measure? When a person creates a video, he often intends it to be viewed from the beginning to the end. Often the punchline comes at the end. Moreover, if a large part of the audience leaves before the end, they will probably not be interested in the next video by the same author. Now, real-time broadcasts. If a person leaves before the end, then they are more likely to switch to another program being broadcasted at the same time, and the chances of coming back to watch the original channel are smaller. Now with YouTube, there is a special feature that the video creator can embed personal recommendations at the end of the video. The option is called End Screen. If a person leaves before the end of the video, then he does not have access to this recommendation. What are the drawbacks of existing measures for retention? We say that two indexes are consistent if a better performance according to one of them results in a better performance with respect to the other. We show that APV and RAR may not be consistent. APV is the average percent viewed, and the RAR is the relative audience retention. An index is continuous if a small change in the retention results in a small change in the index. We shall show discontinuity of RAR in APV. The figures 8 till 10 correspond to the shortened video of the song Sur le Pont d'Avignon, which we created on January 5th, 2015. The duration of the videos is 2 minutes 33 seconds. We checked the average viewed percentage obtained by the same video in 3 different periods in 2017. They all begin at January 5th. Now the first experiment is till February 20, the second one till February 21, and the third March 2. The corresponding AVP are very close to each other. These are 42, 43, and 40%. I'll now show the three figures that corresponds to the AAR, the absolute audience retention of the three experiment, and then I'll present the three figures that corresponds to the RAR, the relative audience retention. And we'll compare them. What we're going to see is that the first three corresponding to the AAR, to the absolute retention, are almost identical, while we'll see large differences in the RAR, in the relative ones. Experiment 2 gives the highest average percent viewed, 43, but the lowest relative audience retention, with a 1-point difference uniformly. This figure presents the relative audience retention in experiment 3. Its APV is 40%, it's the lowest among the three, but it has the highest RAR. We conclude that the APV and RAR are not consistent in this example. We thus have a complete inversion between the RAR ranking and the APV ones. Furthermore, very small variations between the AAR curves result in high variations between the RAR curves. The retention graph of all three experiments are almost the same. And move to the conclusions. Retention analysis enables one to improve videos and to predict their popularity at quite an early stage. YouTube has defined the absolute retention measure, APV and AVD. The shorter the video is, the better are these two measures. Therefore, it is also pertinent to compare videos of equal length. Hence, YouTube's definition of relative retention, the RAR, which is a normalized version, normalized by the length of the video. We show that RAR may not be continuous nor consistent with respect to absolute retention. We propose and study the new LP retention measure, which doesn't suffer from these two problems in the examples that we looked at. Thank you. Any questions?